Good morning. Here we are. We're on topic two. Okay, I say good morning, but whatever for you. I don't know. So, good morning from me. Topic two. This is a very important topic, though potentially not the most interesting in the world, but very critical. So, in this topic, I'm going to break it down into six smaller chunks here to make it a little bit more digestible. Because, frankly, this would be an awfully long, undigestible chunk if I put it in one shot. So, first, I'm going to kind of talk a little bit about what science is, and then I'm going to break up different research methods into the experimental methods versus the observational methods. And then I'm going to kind of have a little discussion about what is measurement. This is kind of a big deal. What are we measuring? A little splurge on ethics, and then a little tiny bit on stats. So, as we had said earlier, IO psychology is an applied discipline, it primarily applied discipline. But what happens is that IO psychologists, many IO psychologists are in fact basic researchers. They do basic research to find the principles of psychology which are applicable to industry, and then the consultants or something will apply them. I remember when I was an undergraduate, I worked with Dr. David Hyatt. In fact, he's featured in here. In anyway, the edition of the book that I am kind of working with here, he's in here somewhere. They put a little box on him, so pretty cool. David Hyatt. He did some cool research, and I can't remember all of the details, but I believe he was doing research on leadership. And so what he did was he was putting together work teams, right? He would bring in, this is an experiment, right? He would bring in groups of people and assign them to different leaderships, right? Different styles of leadership. And then he would measure performance by the group based on, you're going to love this, construction of Legos, all right? They would have Legos and instructions and different types of leaders. And it was very interesting research, but it was very basic. And so the idea is this interesting finding about different leadership styles and Lego structures would then be applied to an organization later on where it would make a difference. Okay, so it's a combination of basic and applied. So what is science, right? You've already kind of got a little bit of a hint on what science is, right? Because science was a blending of empiricism and rationalism, and we're going to find science is a blending of the inductive and the deductive methods of logic. So science is a way for generating knowledge, a way to discover the truth. As we said, religion, philosophy, and science are just three different ways to discover the truth. It's not a better way than religion or philosophy, it's a different way. Some truths of the world, some knowledge is best obtained using religious religion. Okay? Some knowledge is best obtained using philosophy, and some knowledge is best obtained using science. So most of the time you hear about a conflict between science and religion, it's usually because somebody's trying to use the wrong tool for the wrong job, trying to use science to discover the meaning of life, or trying to use religion to discover a truth that ain't not be in that field. Okay, so it's just a way of discovering things. Scientists strive for what a strange phrase that is. Okay, science has basically four goals: describe, explain, predict, and control. And in fact, the psychology, in a lot of ways, can be defined as the science of describing, explaining, predicting, and controlling behavior and mental processes. So, I mean, that's just a larger definition of psychology. And so we're going to talk about different research methods that allow us to describe, explain, predict, and control. Now, what we find is that IO psychologists, as a rule, really are looking on prediction and control. That is the two things that they are primarily interested in. And that is to say, if you want to change the world, okay, again, going back to Francis Bacon, where he says, make the world better, right? Well, anyway, if you want to change the world, or in the world of IO psychology, increase productivity and make more money, you need to be able to, say, for example, predict which characteristics of workers are most likely to predict success, right? Or control. Which elements of my factory should I manipulate and change in order to maximize productivity? So it's usually these bottom two that IO psychologists are interested in. But don't get me wrong, because description and explanation are critical pre-steps, shall we say, pre-steps that are required before prediction and control, which is where you really change the world. Well, we had already talked about certain things here, but science has certain assumptions. There are assumptions, things that we assume, I know, making something, whatever, assumptions. One of them is empiricism. I like this. Science is fundamentally empirical. If you want to know about the world, you look at it. Okay? That's really what it comes down to, looking at, and data is where it comes from. Determinism. This is essentially this can actually conflict with religion a little bit, but it says there is no such thing as free will. Science, if taken literally, it basically says there are laws in the universe, and these laws are deterministic. You think that this morning you made a choice to eat, sugar pops over Kellogg's cornflakes or something like that. But according to this notion of determinism, it was already predetermined at the beginning of time that that was going to be what you did at breakfast time. You have no free will. A causes B causes C, and it is an unchangeable chain. Okay? And this is pretty important because can you imagine? And I mean, I'll just pull it up in the world of physics, right? And I take a rock and I drop it. And somebody says, why did the rock fall? I would say, because the rock used its free will and decided to do so. Wow, that's chaos, okay? You can't predict anything. Nothing is, there's no explanation. In this analysis, free will is kind of like a cop-out for, I don't know the answer, so I'll just say free will, right? Yeah, okay, so there are laws. And then this last one, discoverability. I've never really heard this word used before outside of this course, but this idea is very, very common, this idea of discoverability. And that is that even though we don't know everything, there's nothing that can't be known. Okay, there's no such thing as magic. You can never just say, oh, and then magic happens. Okay, that even if we don't understand it today, it is something that could be understood in the future. So there's no magic, nothing that is beyond the realm of understanding. In science, we generate theories, and we talked about this again previously, right? In the scientific method, generally speaking, what happens is, well, a theory is, by definition here, a set of interrelated concepts and propositions, blah, 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 blah. A theory is a tentative explanation. I've seen some observations, I've saw some things. A theory is, at this point, the explanation that I'm going to use for what I've observed is. That's pretty much what a theory is, a tentative explanation for a set of observations, some kind of a thing like that. But look at this, a best guess about a universal truth. I like that. At this point in time, my best guess is, okay? Well, theories do a lot of things. They help us to guide research because theories help us to generate hypotheses, and hypotheses help us generate predictions. Predictions allow us to create observations, and then the observations themselves come back and allow us to test the theory. Okay? So we find that theories are in some ways the central point of the scientific process. Okay? They are both the starting point and the ending point. Okay, so we find though that some theories are better than other theories, and in other courses you'll take with me, I would absolutely expand on these a lot more than I will here today. Okay, but a good theory is parsimonious, and by that I mean that generally speaking, smaller theories are better. Okay, shorter explanations are almost always correct. Okay. Precision, that they come to a very precise predictions. Okay, if you have a theory that only allows you to make vague predictions, that's no good. A theory that allows for very specific, if I manipulate this particular thing, then this exact result will occur. theories need to be testable. So if you've got a theory about, alien life forms on planet X, but you have no way to test that theory, it's a junk theory, right? Usefulness and generativity are kind of sort of interrelated to each other. That is to say, does the theory allow us to create lots of research questions? Okay, something of that nature. Okay, now we've got this induction deduction, two different types of logical thinking, right? What we've got here is induction is the approach to science that says, I'm going to take some data and induce the theory. In other words, I'm going to look at a series of observations and use induction to generate a theory to explain those observations. Deduction says, now that I have a theory, then I deduce that the next logical thing will be this hypothesis. So you see what we got here is we have a set of observations, we use induction to generate the theory. Now that we've got the theory, we use the theory to deduce which observations we should see or to deduce our predictions. Okay, and so it's a combination of induction and deduction. And so science is great in two different ways, to combine empiricism and rationalism, but also to combine the two different logical thought styles of induction and deduction. And so, yeah, there's just a picture that kind of is a little confusing, but anyway, it shows you where induction and deduction start and begin. All right, so I'll stop there for this particular video and pick up again in the next topic.